Hi and welcome to Math Pre-Calculus 20, Section 7.4, Reciprocal Functions, Example 2. Alright, so in this question we're looking at the function f of x equals 2x minus 5, and we want to determine its reciprocal. Okay, and we're going to end up graphing it in the end. Okay, well, basically to find the reciprocal it's pretty easy. It's just y equals 1 over f of x, and f of x is 2x minus 5. So there's our reciprocal function. Simple. Okay, so now we need to start thinking about this. Okay, we're going to be graphing this. So it wants to know the equation of the vertical asymptote. Okay, the equation of the vertical asymptote, hopefully we're making that connection, right? That's actually where our non-permissible value is. Alright, so what's our non-permissible value for this reciprocal function? Well, our non-permissible value, we could go, okay, well, 2x minus 5 cannot equal 0. Solving that for x, we get x cannot equal 5 over 2. Okay, and in this case it's an equation, like it's basically asking for an equation, so if we were to draw it on a graph, right, so we want it to actually be the line x equals 5 over 2. Right, so that's our vertical asymptote. So our vertical asymptote is wherever our non-permissible values are. In this case, we just have the one non-permissible value. Right, so when we graph this, we know that there's going to be basically a straight up and down line, right, that the graph is going to get really close to, but never actually touch. Okay, so let's move to part C. Part C says to graph the function and its reciprocal, describe a strategy that could be used to sketch the graph of a reciprocal function. Okay, I'm just going to move this over here a bit. Okay, so a strategy that we could use, well, first step we could do is we could graph the original function. So graph the original function. Well, the original function, right, was 2x minus 5. So to graph that, that's just a line, y-intercept of negative 5, and a slope of 2, so up 2 over 1, up 2 over 1, up 2 over 1. Right, and then put a line through that. Right, so something like that. Right, so that's our original function. That's like y equals 2x minus 5. Okay, so now to draw the reciprocal of it. So that's the first function, now we want the reciprocal. Well, we should actually start with our vertical asymptotes. Right, and there could be one or two of those, or three, there could be multiple ones. Okay, well, if we go back to the previous slide, we knew that our vertical asymptote was at x equals 5 over 2, right? 5 over 2 is actually 2.5. So that means we've got a line at x equals 2.5 that the graph isn't going to touch. So that's like there. Okay, so that's our vertical asymptote. I'm just going to label that as x equals 5 over 2. And even if we didn't have this equation here figured out, one thing we can notice is that's any time where our graph, right, crosses the x-axis. So if we had the graph that went through the x-axis like here, well, we'd have a vertical asymptote there. So anywhere the graph crosses the x-axis, we're going to have a vertical asymptote. Okay, next step, easy step to do is find the invariant points. So remember, invariant points are the ones that don't change from the one function to the next. So the invariant points are always going to be when y equals 1 and y equals negative 1. That's where our invariant points end up. So we should have an invariant point here. Right, so that invariant point looks like it's 3, 1. And here, and that's what, 2, negative 1. Right, so those are going to be invariant points. We could plug those in and double check that. So if we did that, it would be Okay, and the one, how would I go about doing this? Just hold on 1 second, let me think about this. So my original function, for example, if I go 2x minus 5 equals 1, let's say I'm doing it for positive 1, and then solving this I'd get x equals 6 over 2, so x equals 3. So we get the point 3, 1. And in the reciprocal function, right, we can see, right, is it actually that same point? Well, it's going to be, I'm looking again for when, this is again when y equals 1, so it's y, so 1 equals 1 over 2x minus 5. Okay, and you probably remember from previous years or previous classes that we're allowed to flip both sides. This is 1 over 1, so we flip this side, so we can get 1 equals 2x minus 5. So that's exactly the same as what we had over there, so we get x equals 3, and so we get the point 3, 1. Okay, we could go through the same work with y equals negative 1, right? So we could go 2x minus 5 equals negative 1 and solve for x and get x equals 2. And we could go negative 1 equals 1 over 2x minus 5, solve for x, and again we get x equals 2. Right, so that's a little bit confusing, but basically we know that we're going to have invariant points again anywhere where y is 1 and y is negative 1. Okay, I'm going to just erase those. Okay, so we have the fact that there is invariant points there and there, and we've got a vertical asymptote there. Well, thinking about other things, well, reciprocal functions, right, they get really close to asymptotes, so I can go from this invariant point here, I'm going to go up, right, and it just gets closer and closer, and it shouldn't cross it, it just gets closer and closer. And then the other part, we also saw from that other graph that it comes right down and gets closer and closer to the x-axis, but doesn't touch it. So we get a part of the graph that looks like that. This other part, I start at the invariant point, I can go along the asymptote again, and starting at the invariant point going the other way, I can go along the x-axis. So there we get the reciprocal function in red, right? So that's f of x, or y equals, I should write it as y equals 1 over 2x minus 5. Right, so the red is our reciprocal function. So how did we do those last steps? We might want to jot down some information about that. So the last step is basically we look as x increases, or sorry, as the original function reciprocal decreases. Right, so that's kind of our rule of thumb. So if we look at this here, as x here is increasing, or as the function goes up there, well, this function goes down. If we look here, it's getting closer to the green, well, so, and this one's going to go up there. And this is a little bit hard to see on here, but once you get the hang of it, it won't be too bad. So as you go through the next couple examples, hopefully this starts to make more and more sense, but again, the basic idea is as our reciprocal function increases, as our original function increases, our reciprocal decreases, and vice versa. So we have our invariant points, we have our asymptotes, and then we have the idea as whatever happens to the original graph, the opposite happens to our reciprocal graph. Okay, so just remember what happens to the original, opposite happens to the reciprocal. Alright, thank you. Good luck.